I think we need to get started. We've got a busy morning, and I just want to welcome you all. My name is Pat Soroyce. I'm the director of the Maine SFI Implementation Committee, and a participant in the Fisheries Improvement Network. And so anyway, welcome everyone. We're not going to go through introductions. I think we're nearly 80 people signed up, so I guess we'll skip that step. We've got again, as I mentioned, a busy morning. Let me just quickly. You've all seen the agenda. We've got actually two segments. The first part more focused on fisheries and habitat issues and restoration and stream connectivity type things. And then in the second session, starting at 10, will be the wood turtle workshop. So that's, I'm really interested to see that section as well. I just want to thank everybody for the work that's gone into organizing this. It's been, we started talking about this, I think almost a year and a half ago. For logistical reasons, we weren't able to pull it off last fall. And then for obvious reasons, the May 21st date for when we were going to do this got postponed. So here we are. It's not ideal, but it is the way we can do things today and still get together. So it has been a fair amount of, like I say, effort by everybody to figure out how to put this on, and both from the fin side on the fisheries piece and also the wood turtle workshop piece. So thank you to everybody, and we're going to work really hard to stay on schedule because that's really important today. We're going to help the speakers make sure they fall within their time slots and stay in there, and that way we don't get backed up into the second session. I'll stop there, and Henning Stabens, if is here, and to talk a little bit more about the day.
Yes, good morning, everyone. Thanks for joining us today. And as Pat mentioned, we split this meeting between the Fisheries Improvement Network portion, this first part, and then at about 10:15, we'll transition to a wood turtle workshop. And we appreciate all the interest in that subject for that species of concern that is up for a listing decision in 2023. And the idea for this combined meeting came about when talking with the U.S. Fish and Wildlife Service and Maine Department of Inland Fisheries and Wildlife, and trying to understand, are there any opportunities out there as a landowner group and including other stakeholders that are part of the Fisheries Improvement Network? What can we all do perhaps to assist that species and perhaps keep that off the endangered species list? So we'll talk all more about that at 10:15, and so that's it. Pat, I'll hand the baton back to you.
Yeah, just if we are recording this, and we'll have, if there's folks that aren't able to attend or some can't attend the whole thing, we are going to record it, and we will post that on the Fisheries Improvement Network site and other sites that we think will be accessible to you folks. Lastly, we want this to be as interactive as is possible. So if you have questions, I guess in the beginning, we'll see how it goes, but you can unmute yourself and maybe ask some questions or send it through the chat, which is probably preferable. And we'll try to find times to allow the speakers to respond to those questions. Other than that, I guess I'm going to hand it off to Josh Wright. And also the speakers, I would ask that you introduce yourselves, please. That would probably work the best, and we'll go from there. Josh, you're up.
Sure, Will. I'm Josh Wright, senior scientist with the Nature Conservancy in Maine. Looking at the list of people, and there's probably most people know who I am and what I do, but my work does include work on land protection, but it's taken a major shift in the past 15 years to looking at waterways and connectivity. And I'll get into a little bit of that story in just a minute. And then currently about half my time is helping river restoration work that we've done in Maine sort of get echoed in other places around the world in the European Union and especially in Southeastern Europe, and with something called World Fish Migration Day. So one of the things that I'm pretty pleased about is that we registered this event as a World Fish Migration Day event. So it's a day, actually a bunch of days leading up to a culmination day, which is this Saturday, when people around the world celebrate their rivers and the work they're doing to restore their rivers, just like we've done in Maine. So the sort of the icon or the what do you call it? The symbol of World Fish Migration Day is this happy fish. And of course we have as our symbol for the fish-friendly waters of the Fisheries Improvement Network is this very super happy looking trout. And that's the goal, really, is to have more fish have more access to habitat, which we believe makes them actually happier. We can't prove this, but they do tend to grow bigger and have more babies. So make the decision for yourself. But we're one of many events around the world. Tomorrow, let's see, today is Wednesday. Tomorrow is another event, a North America event. It's got over 780 people registered for this event that'll introduce the participants to projects around North America, as well as a little bit of flavor of what's going on around the world for World Fish Migration Day. So it's exciting to be a part of this. Exciting that there's so many places in Maine that are bringing people to rivers, getting them excited about the life that's there and how these places can really enrich their lives, as well as healthy rivers enriching the ecosystems around them, the birds, the waterways, and the ocean nearby. So my journey began with the Penobscot River Restoration Project and realizing that we were very focused on these main stem dams and getting fish access from this little tiny sliver of blue at the bottom of the slide to all these waterways. At least that's what the GIS map looked like. What it didn't include was the fact that there's all these tiny little waterways, and throughout these little waterways, there are barriers. They're little dots. And these are road stream crossings that have been mapped everywhere around the Penobscot River watershed. And what we learned is that we don't have a lot of information about where these road stream crossings are. And I wasn't the first one to discover this. I didn't discover it at all. It was brought to my attention by a heap of other people who had been looking at this and saying, you know, we might have a problem here for some of the very things that make our lives so wonderful in the state of Maine, are rivers and streams and brooks and the nearshore fisheries. And if we don't take a closer look and examine and figure out how big this problem is, we're not going to understand the scope of it. We're not going to understand the scope of the solutions. So that work, we focused on some particular watersheds. We all need to focus our work, our limited dollars, to places that have the highest potential. And these occur all around the state of Maine. So as we started developing this theory of change, that is, if we provide information on where barriers are, it allows people to make smarter decisions about where they put their limited dollars to have the highest impact on rivers and streams, so that our rivers and streams are as healthy and happy as they can be. So what we needed to start with was data. We didn't even have good streamlined data to begin with. Dams were just being put together. The Nature Conservancy did an assessment of 33,000 dams in the northeastern US and looked at places where there was great habitat, native fish were still there, and there were lots of river miles to be connected with few dams. And Maine kept showing up as one of the places to do work where we still had a grand opportunity to reconnect rivers in a better way. Can people read the font on this? I realize white on taupe isn't awesome. I'm seeing several somewhat nods.
Yeah,
so we also
good.
wanted to find out where the habitat was. It's not just where there were barriers, because there could be barriers stacked up in places that frankly don't have a lot of potential for restoring these fantastic fish runs. So if we can look at places where there's the best habitat for brook trout, for sea run fish, for state priority fish, high risk sites from flood damage because these barriers are smaller, cold water because we know that's a rare resource for our fisheries and becoming rarer. And also we needed a system for data management. So this was one of the first obstacles that needed to be put together. We needed funding sources, and over the years of the past 15 years we've been looking at this, we've been putting together starting with seed money from private foundation sources to grants. NRCS has been a huge supporter through RCPP, the Regional Conservation Partnership Program, the Conservation Innovation Grant, to help us get boots on the ground, to get surveys done. There's the Natural Resources Conservation Program, which is an in lieu fee program to get money to specific places. So all these funding sources are limited and need focus. So that's what our work helps do. I list some other sources here as well. We needed education, which we severely lacked. We didn't know necessarily what made a good road stream crossing, but luckily folks around the Northeast, particularly a hub of education at UMass, was really looking at what are the metrics that would make a road stream crossing passable. How do we know when they're not passable? And what can we do to fix them? So sharing lessons learned. And a lot of those lessons learned came from the Fin workshops that Pat's been coordinating all these years. And many of us have been joining to share our information. This is what we know about the species. This is what we know about solutions and products that are up there. Here's some innovations from the field where they didn't have access to any fancy equipment, and yet they still made do with some really fantastic innovations that Fin allowed us to share in a safe environment where people could learn about, discuss, and do better work because of it. The Department of Transportation also joined in these efforts through the Stream Connectivity Work Group and a short-term collaboration called ARMS, which was to get people looking at road stream crossings around the state and coming up with solutions for rivers, and demonstration sites, which again, the Fisheries Improvement Network was vital in terms of bringing together people to see what these things look like, because there's nothing that helps you visualize what the correct solution looks like or what an incorrect solution looks like than being there and seeing it and asking questions to experts. We also needed analysis and prioritization. So it wasn't just the stream network, but we needed to calculate along that network miles of habitat. What happens when you go up one trib and then tributary off the trib? Well, the new tools that were developed over the past decade, really 15 years, I should say, have helped us analyze stream networks in new ways. And they're also helping us look at priority places for habitat as we connect the streams and the barriers to the wildlife habitat. We can look at flood models and find out where road stream crossings are likely to fail. And we can optimize solution sets so that we're removing barriers in the places that make the most difference the quickest, to see the response in the ecosystems, to see the safety of the road networks improve. And also having the data in this analysis allows us to look at cross-owner collaborations. Are there places where towns and large forest landowners, where the state of Maine could all work together to improve a stream network? We couldn't do that before we started to collect data and analyze it. And then there's actually putting the projects on the ground, implementation and monitoring. So what's the innovations that have happened over the years? Certainly things like arch culverts, things like these modular concrete arches, the waste block bridges. There's been a lot of fantastic innovation that's mostly come from you folks working in the field and trying things out and seeing how they work. And then local businesses saying, hey, this might be an opportunity to make some money and grow our staff and create a new product that's useful. And this has been happening throughout the state of Maine, not just with the large forest lands, but also with municipalities and the state of Maine, who's really made huge steps in terms of how they look at road stream crossings. I included dams in here too, because of course dams are barriers in streams. We've learned about more where they are. There's still a lot out there in the landscape that we don't know about. Sometimes the landowners don't even know about some of these historic log drive dams that folks like Project Share have been working to identify and get out of these systems, where they create not only hydrologic barriers, but also sometimes temperature barriers to movement of species up and downstream. And then we've also been working collectively on regulations. How do we ease requirements for these road stream crossings so that it's easier to put the right thing in than to put the wrong thing in, so that we are cut a little bit of slack when we're trying to repair streams for endangered species with the Endangered Species Act, and to make the permitting process a little bit more predictable. And that means not only having regulations that make more sense for this work, but having the education within the regulatory committee so that such that they understand what we're trying to do and the people that are doing it and their skill sets. So all this is founded on that basic base data of where are the barriers. And this is a composite slide that Alex Abbott put together. And the whole series you're going to see coming up showing the barriers is something that Alex put together for a celebration of the end of the road stream crossings work and the end of the first round, I should say, of collecting data. So we've covered every watershed around the state methodically, year by year, with Alex at the helm, not only sort of creating the maps and figuring out where to work, how many sites there might be, methods of how to get there, finding out what landowners are where so that we make sure we have appropriate outreach whenever we can, and also training the crew, making sure they're trained well, make sure the data is accurate. There's 1,000 different things that need to happen for this work to come out. And this composite is a picture. There are thousands, there's about 65,000 photographs of road stream crossing in the state of Maine now. And Alex had this program that took each one and put them so that they would bring in the colors of this photo of a fixed crossing. Pretty cool little program. So thank you, Alex, for that. And a lot of this work wouldn't be possible without the sort of the foresight and the innovation in terms of, one, thinking of the idea and how we can work together to solve solutions, but also how can we fund this and how can we get funding to get people out in the field, and let's think outside the box and bring in pictures, bring in people from all the different agencies and all the different local organizations to lend a hand in doing this. And Jed had that insight. He had that ability to work with people and the know-how within his agencies to bring money to bear. So we lost Jed tragically in 2017. Mental health issues, which were horrible and unbelievable for most of us who knew Jed. And yet things like this happen. So I put a plug in there for understanding people's and the world of mental health treatment so that we can get better and not lose more incredible people like Jed. We've set up a fund with the Atlantic Salmon Federation. We're still raising money for this fellowship, which gets young people out on the ground learning about road stream crossings, learning about river restoration. And this year we didn't have an intern. Last year we did. This fantastic woman from Fort Kent. And we'd love to continue to raise the bar on this funding so that it is lasting for longer, because it's an endowment. It needs to spin off interest. So please, if you can, if you or your company personally, however, could donate, we'd love to grow this fund for the Jed Wright Fellowship for River Health. So this is a great series that Alex put together, which showed our progress over time. I'm going to buzz through it pretty quickly. But starting in 2007, as I mentioned, in the lower Penobscot, below where there were dams, let's find out where fish do and don't have access to. So that's what started out with a lot of volunteers. And Alex, with methodology that had been developed with him and folks at UMass and others in the Northeast, got the methodology, proofed it on the ground, found out what worked, what didn't work. One of the things we found is that when you train people and go back and retrain them and check the data, you're going to come up with a much better product. So over the years, we started filling in the Penobscot. Again, this is with the leadership of Alex. The Maine Forest Service was involved. Melissa Laser at DMR was involved, and Jed and Alex, of course. Chris Martin, it was the name I was trying to think of for Maine Forest Service. So got crews out there, and slowly other partners started jumping in, like Friends of Casco Bay, folks in the Kennebec Estuary Land Trust, Trout Unlimited, Western Maine, all started chipping in. And around this time, the Nature Conservancy realized that these professional crews were collecting better data if we got 2 or 4 paid for the whole summer or longer. They could really get in the swing of it and cover a lot more ground. And so with that, we started funding this. NRCS started chipping in for about half the cost of the surveys. And you can see how much more quickly the state is becoming filled in, until finally in 2018, and then October 2019, the last watershed was completed. What does that mean? It means 13 years of surveys, over 30 organizations, 225 people helping out the process. Keep my eye on the time, I'm doing all right. They also caught a lot of dams that had not been surveyed before. What are the heights? How big a problem are they? Where are they in the network exactly? So what we've got in the end is over 26,334 barriers. I mentioned these photos, 74,000 photos, all in this enormous database. Turns out over half of them are barriers of one sort or another. Less so on the private timberlands, more so on the municipal lands, roads that is. And there are a lot of places where there seemed like there were crossings, but there aren't anymore. Roads were disabled or taken out. So amazing results. No other state has a database like this. I work with a lot of other countries. None of the countries of equal size or even have basins the size of Maine that have this amount of survey done. And so super exciting to have these on the ground surveys done. And amazing look at the state of Maine that we did not have, which basically shows there are great places and there are places that need help all over. So it's a problem that everyone has, and now it looks like all people are helping to do this. So what does this look like? Just a close up from the Nature Conservancy's own land, where we've got this barrier clogged up with sticks. It's kind of undersized to begin with, which is probably why it got to that condition. And here we have bridge impassable due to road eroding. There's brook trout habitat upstream, and this is a good place to make probably a bigger structure, which we have. So here's some of the worst looking barriers, a collection that, again, Alex put together for our celebration with the stream crew last spring for a different World Fish Migration Day event. Some of the things that you can see right off the bat would be tough for a brook trout to make it up. And here's some fixes that are almost there, but not quite right. You can see the scour happening around the base of this. Here's a larger restoration site into a very large shallow arch, beautiful site. Another site clearly impassable for just about any fish. And here's what it looks like now. I believe with Dan, said Dan Kirchhoff in the NOAA, another beautiful site going to a bridge, a span. Here's those concrete arches. Another site sort of falling apart. You can see it's a mess, and took a lot more to get this site open and get in what's a beautiful bridge today. So I'm gonna buzz through the last of these and some pictures of the crews. And you might say, well, are we done? Well, we did get every watershed a lot of coverage. There's still gaps. We need to focus on filling gaps. There are priority places that need focus. We need to track the cumulative impacts of this work. How are we doing? How can we do better? We need to justify to agencies and others, including the large landowners, that this work was worthwhile. So we need to keep it up to date and relevant. It's a model for other places around the world, as I mentioned, certainly around the country. And it only works when the database is up to date. So we sort of need this feedback loop. It's something that we've been reaching out to landowners individually, but I think we need to develop better systems for keeping the data up to date so that we can rerun the model, keep the data relevant, and better foster collaboration along partners, whether they're other forest landowners or the state. So, so here we go. This is our celebration of the crew, and this would not be possible without, as I mentioned, someone who had the foresight to pull this together, the patience to work with enormous data sets. And this is Alex Abbott, who we really need to honor for his work around this project. He nurtured, mentored, was able to carefully manage things going awry during the field season to keep things going, making the maps, checking the data. And for this, Alex is getting a plaque presented by his wife, Jennifer Melville. And Pat, do you want to present the plaque?
Yeah, well, so we're thrilled to do this, Alex, for all the hard work. And I'll just read what's on the plaque. It says the Maine Fisheries Improvement Network, outstanding achievement for 2020. With our deepest gratitude and respect for your undaunted work, training, coordinating dozens of crew members, mapping and analyzing Maine's stream barriers, watershed by watershed, all for the betterment of our rivers, streams, and the ecosystems that thrive when they are restored. Your thoughtful insights, passion, and patient education has made us all better observers and stewards. The Finn partners proudly present this symbol of outstanding achievement to you, Alex. Congratulations, Alex.
Congratulations.
Wow.
So thank you so much, Alex. I'm going to stop sharing so we can see more faces. But thanks everyone for this project. It's been amazing. I'm honored to be a part of it and get to work with Alex, especially over these years, and this partnership with all of you wouldn't happen without careful thought and really our love of these rivers and streams around the state of Maine. So thank you, Alex. Thanks everyone. Alex, did you want to say a final word? We've got a couple of minutes before our next session starts.
Thanks, Josh. Sure, I would like to say, and I think the main thing to say, well, aside from thank you to everybody, is of course, this wasn't, I appreciate the thoughts and the award. It's been wonderful working with Finn, with all of you for so many years, but of course, this is a gigantic collaboration. There's no way any of it could have happened without all of us pulling together to do this work. I mean, I was just coordinating a variety of things. I was a little part of this bigger system, and I'm really happy that it's gone as well as it has. Also, as I hear you run through a lot of that, having thought a lot about it, I remember how tired it makes me feel about all those years of work. But I think it's just been a great foundation for so much else that's happening now. And that's sort of a springboard into my little presentation, which I'm going to do coming up next. Getting away from the initial rapid survey approach of knowing what's out there on the ground to getting these fixes done that really most of us are, of course, focused on. So thanks.
Thank you, Alex.
Well, you're all set to go, Alex, if you're ready.
I am. Let me share my screen. Let's see where we are here. Hopefully it works appropriately if I can. There we go. Sorry. Okay. Can everybody see that?
All good.
Okay. So I will give a little introduction. I guess Josh has given a lot of it, but I'll just clarify a couple things too. So I call myself a stream restoration specialist, but I'm essentially a contractor, a partner, a cooperator. I get called different things. I've been working with the U.S. Fish and Wildlife Service for over 20 years now in the capacity as a GIS analyst, a cartographer, doing lots of different things. But it's in most recent years that I've been much more involved in on the side of actually doing the restoration projects after we had, as Josh pointed out, collected all that stream barrier data. I've been doing for years a lot of work learning and then also teaching about stream simulation design. So doing a lot of stream assessment work, also doing design work, and actually doing a lot of construction oversight in the field. And some of that has been done, a lot of it really, in association with Maine's Stream Smart program with Audubon. So I'm under contract often, I've been under contract to the Nature Conservancy, to Maine Audubon, to a whole bunch of other organizations. I work a lot these days with Katahdin Woods and Waters National Monument. So I'm in sort of an odd position, but it's a really happy position, in part because I get to go from soup to nuts. I get to do some of the initial assessment work, like this site that was identified back in 2010 by the Maine Forest Service crew, then connecting with the town of Starks, where this site was done, and actually doing the full stream assessment, a design for them, and then helping them to put together a DEP culvert upgrade grant, and actually building it this last year. And so I am thrilled to be able to do all of those different pieces of this. And it brings up one of these points that I've been really harping on a lot in the Stream Smart program, and I just wanted to touch on with all of you today in a variety of ways about building stream crossing banks. And so part of this is about why we build stream crossing banks, and part of it is about how. And I think we've all been doing a much better job of this, but I think it's really worth reiterating, because what we're after, of course, is true connectivity. We're after aquatic connectivity, but when we say that, we're talking about ecosystem connectivity, really. And while we love fish and we're here to talk about the Fisheries Improvement Network, we're also here to talk about wood turtles. And let's not forget the other critters that we know the reason roadkill happens is because critters don't really want to go up and over the road. They much prefer to follow stream channels. And I have spooked many a critter hunting, living, traveling in newly replaced culverts, even old culverts. When they have a chance, they prefer to follow the stream channel. And so terrestrial passage is certainly part of this whole thing that we're talking about. So when we first started this work many, many years ago, we certainly knew that fish passage was key. And that's one of the things that got us some initial funding. We were thinking about salmon, we were thinking about brook trout, and it's still critical. We can't build good stream crossings and not consider fish passage well. But of course, along the way, we've also started to talk more about aquatic organism passage, or the full suite of critters, meaning aquatic invertebrates, insects that are the base of the food web for these streams. But certainly more and more, we're also acknowledging the need to accommodate terrestrial critters in building our stream crossings. And so I want to talk more about that. And it's not just about those critters. There are really good other reasons, 3 primary reasons that we build these banks. And most of the time, of course, we're building bottomless structures these days, 3 bottomless boxes, open bottom arches, we call them small bridges. And the wonderful work that so many members of FIN have been doing for so many years on private forest lands really gets at this well, because so many bridges have been built over many, many years, long before I came on the scene. I see them all the time, saw them the other day, timber abutment and timber decked bridges in many, many places. People have known this was a very sensible thing for a long time. We're trying to just make slight modifications to that. But building abutments for these kind of bottomless crossings can be done in a variety of ways. Timber, probably not the best way. We're moving to concrete for longevity purposes, but those abutments that we build don't necessarily, as well designed as they can be, stand so well on their own. They really want armoring. They really want help. And so we'll talk a little bit about that. But also this whole process that I mentioned earlier, stream simulation design, we'll call it stream smart design, is all about mimicking streams, right? We're trying to build stream crossings that reflect the natural dimensions of streams. And so that means the stream form, and that means providing for a low flow channel. That is concentrating flows during low flow times to the maximum depth, such that fish and perhaps other critters in water can move through those areas effectively. So that's all part of the reason for building these banks. And finally, certainly terrestrial animal passage is a part of that. So here's an example of why we armor. This is a concrete bridge, a concrete abutment and concrete decked bridge that has shown the tests of time and the abrasion that comes from particles in the stream, gravel and cobble and other things, but also just water and the chemistry of the water over time, degrading even pretty massive concrete abutments in a structure like this. Armoring is needed because of scour, one way or another. And so that's one of the things one of the reasons we do it. Here's an example of a small bridge on a major haul road up near Katahdin Woods and Waters National Monument. I'd like you to focus on the upper left photo. I think folks a couple of years ago noted that the bridge seemed to be dropping a bit, and it's because underneath the abutment blocks were subsiding. Scour was pulling material out from underneath them, and they were subsiding, such that even less than 2 weeks later, another storm came, and you look at the lower left photo, you see that just within a really short matter of time, additional scour happened and dropped those blocks. This bridge would not have lasted if fully loaded log trucks tried to pass over it. So we sort of swept in, and I came in and did a quick assessment, came up with the design. The top right is just during construction, seeing some of the laying in of bank material against the abutments. And the lower right is what it looked like a year or so later, showing that kind of proper stream form, appropriate cross section, banks inside the crossing with a low flow channel in the middle. I just want to show you a few details about it because I think it's important to acknowledge it's not just about the banks, but this is my design drawing I initially did, showing that the abutments are well below the stream bed. the original stream channel and bridge are represented essentially by that gray box in the middle. It was a smaller crossing. It's true, we made it wider, but not a heck of a lot wider, but maybe 50% more capacity. But the original blocks of the abutments were set pretty much at stream grade. And we've seen quite a lot of that. And so they were really open to scour. They had no banks, no protection, no armoring, and they were too high. So we addressed a variety of things in this improvement, but critical to that, expecting these abutments to last possibly 75, even 100 years with inevitable redeckings if we're going to keep using timber. It could not happen really well unless we armored those abutments effectively. So that's a key part of our building of banks. And one of the natural questions, of course, that comes up, I don't want to go too much into a lot of the details, but I wanted to touch on this because so many people here, I think, are involved in actually building these better crossings. And we may need to think a little bit about the practicality of this. We need to know what rocks are appropriate to armor abutments with. And so for the most part, the evidence, of course, is all around us. If we look upstream and downstream to what we call our reference reaches, you can see what rocks are not moving. And it's those rocks that give us the simplest guide to what we want to put in for armoring. I have a little spreadsheet I use where we record key pieces that we measure, all 3 dimensions of, just 10 or 12 pieces or so. And that gives us one really good sense of the kind of stable rocks we need to build banks with. I have another little spreadsheet. It's actually part of the same spreadsheet, and I'll provide this to anyone. Using a formula developed many years ago by the Army Corps of Engineers, which looks at elements in green boxes here on the sheet. There are only 3 things you fill in. One is the discharge, and we're always looking at a 100-year discharge. When I'm doing these plans for stream simulation design crossings, you enter the cubic feet per second discharge, the active channel width, which is essentially the bankful width, and the slope, and it gives you a unit discharge, which gets at appropriate sizing according to the Corps for riprap. This is angular riprap for stable, properly installed blankets of riprap in anything from irrigation ditches to stream channels. And it's a good double check that in this case, I've given you measurements in both feet and inches to think about the stable rock sizes that would probably be necessary inside a crossing that is subject to these kind of flows at these kind of dimensions. So I'll send that out to Pat, and anybody can get that if you want. We call it ESM, or engineered stream material. And we always do a pebble count, a full count of the full distribution of rock at streams to give us a sense of what's moving and what's not moving in streams as well. And so all this stuff together kind of helps us to get a good sense of what rock needs to be used for armoring. But I certainly have seen in the field far too often the rock not being big enough. And so we're always thinking about making sure this rock is going to be stable. And that happens in a variety of ways. Number one, these photos are numbered just to go through step by step in the process of doing the armoring that was done this summer over in the town of Charleston, where we did a bunch of crossings with Dirigo Timberlands. So we're putting this rock in layers, filling voids with fines in photo number 2, adding more rock, adding more fines, building these things up in layers in a way that provides a really stable bank where rocks are locked together and voids are filled with fines. So it's really important that this be done effectively to keep alt water up in the stream. Otherwise, what some of you may have seen in the past is a fully rip-wrapped stream bottom and stream banks allows water to just flow right down in and disappear and not flow properly through the stream crossing. So our main goal usually in a year unlike this one where we have water available is we'll water in those fines, we'll fill all the voids, and it works great. This summer, this summer the lower photos are repeats, but we had no water. We literally, without bringing in a water truck, we had to actually stick with this layering system of very carefully laying in enough material that would really lock these banks together. And I just wanted to touch on the idea that in reality, out in the woods, so often what happens is we don't have angular material to use. And so we use round rock. And it's really important that we oversize that. Otherwise, it's simply going to move. Round rock rolls, round rock is more easily moved. And so we always oversize, maybe by 50% when we're building banks and armoring with rounded rock. I kind of do this out of sync, it seems a little bit here because I could talk a lot more about assessment, but I wanted to at least touch on it. We go out and we do a bunch of bank full width measurements whenever we're doing our assessments, and that's critical because it tells us the width, appropriate width of the structure. But really, cross sections are key, at least one in one good reference reach. And I just wanted to show you these in part to see very clearly that when you do these cross sections, you see a low flow channel appear in every single one of them. These streams naturally create that low flow channel. We need to recreate that low flow channel when we're creating stream crossings. And so in my little designs, my cartoonish drawings, I'm always drawing these as sort of a broad U-shaped or sometimes slightly V-shaped channel where we establish a low flow channel. We give the opportunity for a low flow channel. We really want to make sure that we don't do what is often done out there with box culverts, with metal bottoms or concrete bottoms, and sometimes even natural bottoms, and that is creating these crazy sort of featureless flat bottom crossings that don't concentrate low flows. Sometimes they're passable. Maybe there's enough depth in here for fish at most of the time, but frequently what we see is that there isn't. And so it's just a fundamental aspect of building banks is they help to focus low flow and create a better geometry for the stream. So I wanted to show you a few additional photos of that. Some of them are a little raw post-construction, but it's really, it's not rocket science, obviously. It's just something we always want to focus on, and it's something that takes a little bit of extra effort, but I think when it comes down to cost and time, it's a very minor thing. We're going through a lot of trouble to replace this entire stream crossing, or these entire stream crossings. It's a very minor adjustment to make sure that we do things properly in building the banks. One of our goals, of course, is to match the height within the structure to natural banks. And so that's pretty straightforward, makes sense, right? But what doesn't always make sense is that the last thing that we usually are doing in closing up a stream crossing is to armor the road embankments. And so if you look, say, at the upper right corner, you see these gigantic boulders. Typically, there's riprap used, and it's just dumped at the corners, and it then ends up blocking these beautiful banks we've made and tried to connect to the natural bank. So that's a last item that always needs to be addressed when we're thinking about building banks. They have to connect, otherwise they don't fulfill all their purposes, certainly when it comes to terrestrial critters. I just wanted to close with a few photos of sites that we've done thinking about imagining terrestrial critters, trying to get through something like this versus something like this, that site in Starks. Sites like this that have been transformed to much more natural looking sites like this. And all of these basically, if not on private property, done really inexpensively, by the way. These are not Cadillac projects by the old standard. And they all address the passage of water, fish, aquatic organisms of all types, including terrestrial critters. And it's especially thanks to the members of the Stream Connectivity Work Group. I sort of represent them in some measure and want to thank them, including all of you, for your support for this good work. And I'm pretty sure I have a bit of time left, and I hope folks have some questions or comments about this work.
Alex, this is Pat. So you're suggesting sort of a parabolic feature to the stream crossing is better?
Yeah, I'm not sure I'd call it a parabola, but I guess, but certainly this U-shaped stream. Some people draw it, engineers sometimes draw it as a V. We don't know where the stream's going to choose to put that low flow channel, but we certainly want to give it the opportunity. And then it depends very much on what the substrate is that the stream is calling for. When it's sand and gravel, fine gravel, it's easy because the stream will take care of itself. When we've got a really bony stream, it then takes a little bit more thought about how we want to make that shape happen. And sometimes it has to be a little carefully done with rock ribs installed at a sort of shallow U shape to really try to mimic what the stream looks like up and down. Those are the steeper streams with a lot of bigger rock make it a little bit more of a challenge.
Okay. The other comment I'd make as it relates to your points on making sure there are fines into those larger stones. A parallel is that this year we've done a lot of work with grader operators on road maintenance and construction. It's an amazing what role the fines play in maintaining the quality of a road. Without those fines, you have no binder. And that's been one of the things that I know I've benefited from learning about this year, is how important those fines are and how difficult it is to maintain in a year that's as dry as it has been this year.
Right.
Pat, this is Steve. I have a comment.
Go
Hi,
for it.
Steve.
Okay, just supporting what Alex is saying. First thing I want to mention is everything that we're talking about here. I'd like to always give proper credit to the U.S. Forest Service. What we call Stream Smart is actually based on stream simulation design that the U.S. Forest Service has put a lot of time and effort. This isn't just guesswork. They have a team of engineers, hydrologists that put all this together. And what Alex is talking about in these banks is, super important. And practitioners in Maine are doing this very inconsistently. So it's like we've hosted the U.S. Forest Service coming in, I think it's 4 times now since 2005. But as implementation of these kind of crossings is increasing, there's a lot of people that have gotten second and third generation information from the Forest Service, and some of the details of this don't transfer as well as they should if you took the training directly from the Forest Service, if you get what I'm trying to say here. And over the years, I've seen a number of sites implemented by a number of different people who get it 90% correct, but this is one area that is falling through the cracks. And because I don't think we've had good enough training consistently, as the snowball effect of replacing crossings correctly has increased. So something we may want to think about is, a workshop for practitioners, if we can get them attend, because, the sizing of the material to create the banks, protect the structure from scour I've seen it being very inconsistent. And so it's like, I understand the concept, but I've never been trained on the details is out there. So just something to consider.
Okay. Last comment, Alex, before we move on to our next speaker, again, congratulations. There's a little anecdote I would like to have said before. A couple of years ago, I think it was in 2016, the Small Woodland Owners Association had a chance to get a grant for a couple stream crossings down in Standish, and they needed some information in a hurry. And Jed and Alex were breaking through the ice to do a stream profile in November with Hunter Orange on. So I just mentioned that to bolster the credibility of their dedication. It's pretty amazing. So Mary, I think you're up next.
All right, let's see if I can get my screen shared. Alex, can you stop sharing?
Yes, sorry, Mary, I just did. Yeah.
That's okay, thank you. All right, can you see my first slide?
No, not yet.
It's not sharing? It says it is from my direction.
Just go ahead and maybe redo it, undo it and redo it.
Okay. I can. Now it won't let me show taskbar. How do I get it to unshare?
It should be
Linger at the top of the screen. Let's see.
should be a stop share.
Oh, there you go.
It's coming.
All right,
Here we
Hey,
go. Perfect.
got it. If I punch enough buttons, eventually it'll work, right? Okay. Well, we've heard a lot so far. Actually, I'm Mary Gallagher. I'm the native fish conservation biologist for Inland Fish and Wildlife, and I have been dwelling on these kinds of issues for about 19 years now with the state of Maine, and have been working with Alex and Pat and everybody in the Fin group in general for quite some time now. And it's always been a great opportunity to converse and collaborate with you all. My role in a lot of this has been kind of trying to focus efforts on where we think we can give the biggest bang for the buck for our wild brook trout resources in this state. And brook trout, of course, are an iconic species for the state of Maine for a whole slew of different reasons. Everybody certainly loves to angle and catch a nice, wild, beautiful brook trout in Maine. But they are also a fabulous indicator species for what is high quality, good quality cold water fisheries habitat in general. And that is what we are all about here up in Maine, is conserving and protecting our special areas for our wild fish, our native fish, and most definitely our wild trout. So for quite a few years now, and this has been kind of an effort bubbling along, for geez, how long, Josh? 3-4 years we've been working towards prioritizing brook trout areas and habitats in general. Josh has been a huge help in this effort over the years. But I've also been collaborating and developing kind of tools to help us address a variety of habitat priorities in the state. And I'm going to introduce a couple of them to you today. The first, and just to kind of bring us back to why, there is an entity called the Eastern Brook Trout Joint Venture that Maine Department of Inland Fisheries and Wildlife has been involved with from the beginning, and it is a range-wide conservation for Eastern brook trout all up and down the East Coast of the United States. And one of the primary goals of this large-scale multi-state effort is to conserve, enhance, and restore our wild trout populations that have been impacted by habitat modification, non-native species, and whatever the population level threats may be for a given area. But for a state like Maine, Maine is huge with a lot of water, and we have a bountiful trout resource, unlike many of our partners in other states to our south. So how and where do we focus our efforts? We are a small agency with an even smaller staff and an even smaller fisheries staff that dwells and addresses issues such as this. So for a couple of years now with the assistance of Josh, and I will say that DMR has been kind of involved in this effort for diadromous fishery prioritization efforts as well, but I'm going to focus on our brook trout component today. So we've been working towards developing priority areas that offer our best opportunities for protecting, enhancing, and restoring our wild trout up here in Maine. And kind of a secondary goal of the EBTJV and us as well here in Maine is to work and encourage partnerships to address some of these larger scale issues, because in reality, it is out of the focus of a single entity to address some of these larger scale issues. And with the Fin group, I'm often reminded that brook trout here in Maine are really a forest dwelling species for the most part. Granted, we have trout occurring statewide and across all habitat types, and that's a wonderful thing. But where we're focusing our most of our brook trout conservation efforts is in the forest lands. And I'd like to keep it that way. As the native fish conservation biologist, I think it provides us our best opportunities for maintaining our trout resources into the future. All right. So how do we do this? How do we develop priority areas for inland fish and wildlife for our wild trout? It ain't easy, and it has not been easy from the get-go. But basically what we have been slowly building and compiling over the years is efforts to identify our best current and potential future habitat for wild trout. Now, identifying kind of areas that might fit into this category of future habitat is rather important. Historically, brook trout occurred statewide. That is no longer the reflection of our resource on the ground today. We're aware of that. But we also are quite aware that there are areas in the state that no matter what we do are probably never going to be conducive to maintaining and restoring a wild brook trout population. That's an unfortunate reality of our world today. So, but where are those areas that maybe with a little tweaking, a little effort, we can bring back into full condition and restore a wild trout resource or enhance it if that's all it really needs? It's just a little care and fostering. So through this effort, it's largely a huge synthesis of lots of information that has been gathered by our staff for decades now. My efforts on this kind of effort began when I first started working for the agency, and that's slowly building and compiling and transitioning some of our historical data information into more user-friendly, mappable formats. And as with this current data set that I will be showing you in a second, a large component was actually compiled over the last 2 or 3 years, where Josh and I really focused on picking the brains of our regional staff to get their information and best professional opinion on their knowledge and history of the trout resources in the regions that they have been managing for many of them now decades. So it's an amalgam of both kind of data inputs, our hard survey information of when we go out and actually survey sites and collect information on the fish that are there, as well as picking the brains of our staff who are more than knowledgeable on these types of issues. So what we have done is basically classify the stream networks across the state of Maine, no small task, across kind of a range of information types that kind of synthesize and collect information on overall habitat condition as well as the existing brook trout resource there at the time, i.e. current conditions. As part of this effort, about 35% of the state's river and stream networks have been classified as some level of wild brook trout habitat. Now, our classifications are 5 broad categories where we're classifying things on a basic values judgment. So it's low, moderate, high, and very high value. And then there's a 5th category that we currently call not, for lack of a better term, that are brook trout habitats, but may not be the best places for connectivity enhancement because of known invasive species issues not far downstream. So that is an additional classification that is available to us as part of this effort. Now, we're also highly interested in focusing our efforts in where we can provide the best bang for the buck for maintaining and conserving our wild brook trout and our habitats going into an uncertain future. So we have taken all of the areas of the state that have been classified as high or very high in our brook trout habitat rating effort, and these are currently our priority areas for wild brook trout conservation. So the intended primary use is to provide this information to groups like Finn, as well as any landowner willing to work with us and interested in providing a stewardship component to wild trout habitat. And what we're hoping for or striving for is these are the areas to target for improving stream connectivity efforts for wild trout, as well as in-stream habitat restoration like wood addition, log driving, dam removals, you name it. There's a variety of options that may exist across our landscape for improving the habitat conditions for wild trout. So here it is. All those green areas highlighted in the state are the identified stream and river networks at this point in time where we're very confident that these are high quality areas for wild trout conservation and management into the future. It's about 22% of the state's flowing rivers and streams in the state right now have this priority area designation. This is simply a designation from IF&W to provide to the people of Maine and our conservation partners, as these are areas where we will be willing and collaborative partners on moving forward with restoration goals as they develop and whatever the action that's appropriate for that area may be. Come talk to us about what options may exist in these areas. We'd love to work with you. These data are shareable. Right now, it's simply a GIS data set that is available to share and with you and your GIS people. I'd be happy to do that. We're investigating options for how to make these data more shareable in the near future, so stay tuned for additional areas or opportunities to get a hold of these data. But if you're interested now, just shoot me an email, give me a phone call, and I'll figure out a way to get these data in your hands, and let's start talking about some cooperative conservation if opportunities arise, or you think you might want to try something. So that's one input. These are the areas where we know wild trout exist. Our populations are reasonably robust. The habitat may not be 100% perfect. Opportunities may exist for improving connectivity, wood addition, you name it. This is now ready to roll. Now, the other kind of piece of brook trout conservation over time, and this is just a zoom in on kind of a finer scale area. It just delineates and highlights individual stream segments as priority areas. So if you're proposing a harvest in these type of areas where wood addition might be something you want to consider for incorporating into your harvest plan, and one of these red streams or whatever color you designated in your GIS pops up, I'd love to talk to you about opportunities. Now, one of the other things that's important for wild trout is maintaining cold water, or as much of it, across our landscape as we can. We are in an era of climate change, and what we're trying to get a better understanding across the landscape of Maine is where areas are likely to remain cold enough for cold water fishery management, especially wild brook trout, as conditions continue to change. And the jury is really still out on exactly what's going to happen here in this state due to climate change. But step one of figuring out where things are likely to stay conducive to maintaining trout is let's develop some models and figure out what our current conditions really are across our landscape. So one of the things, and I believe I've spoken with this group before about this, but we've been in IF&W have been involved with an effort for, about 8 years now, with a whole slew of additional partners out there. U.S. Fish and Wildlife Service has been a big one, to develop a stream temperature monitoring model for the state of Maine. And this is all part of the Northeast Stream Temperature Model in general. USGS and U.S. Fish and Wildlife Service are doing this across the Northeast region. It's not just the state of Maine. We're one of the many partners involved with the larger effort, but the models for the state of Maine are finally starting to show some promise for helping us on some big questions that are out there. Now, the model is developed. It was developed by the USGS and some contractors and collaborators with the USGS. You can access the data inputs, or model outputs at either of these websites. And I'm sure Pat will share this presentation with you so you can get that web address for you if you're interested. But the factors that definitely affect stream temperature that the model, as well as other modeling efforts in similar venues, have shown time and time again, are these kind of suite of variables that I've listed here. Total drainage area, and this is at the individual site. All of these pertain to the individual site where a data logger is in place in a river or stream collecting stream temperature data year round. The impounded area upstream, agriculture within the watershed, the percent of high level of development in a watershed, the level of forest, especially within a large riparian area, relative to where you're logging, is a huge influencer on stream temperature. Precipitation patterns certainly play into it, whether it's short-term or long-term. Air temperature regimes affect stream temperature as well, whether it's also short-term or long-term. And these are all things that are kind of commonalities when you're developing temperature models. And if anybody is a real math nerd, I'm not. I vaguely remember symbols like this from many years of school. But here is the model if anybody's curious, and this is the reference. And I can provide this paper if anybody is really curious about it. Where we are monitoring stream temperature in the state of Maine is kind of the map displayed here, where all those blue dots are long-term, year-round data logging stream or river temperature stations around the state. And it's not just me that's out there doing this. This is a lot of partner effort. A lot of private landowners are involved, watershed groups, NGOs, state and federal agencies across the board, Penobscot Nation, huge broad partner coalition involved in this effort. Within IF&W, we are monitoring about 81 sites. These tend to be these blue dots referenced in this map here. The USGS modelers take all of these data that are collected on an annual basis, crunch the numbers down by watershed, by HUC of varying scales, and develop these stream model outputs. In the ICE tool, you can access the model results today, and there's a variety of outputs that are available for users to look at and explore. Here's the stream temperature model variables that are available for you to map at whatever watershed scale resolution floats your fancy. But the things that we're interested in the brook trout conservation world are, of course, what our mean summer temperatures really are for a particular site or watershed. We're also interested in what we think is going to happen under various climate change scenarios. And these are the three outputs here of a +2, +4, or +6 degree change in atmospheric temperature, as well as the numbers of days per year that exceed certain temperature thresholds. And these are important for cold water fishes in general. But the big kickers are 18 degrees C. You get over about 18 degrees C, it starts to become stressful conditions for most of our cold water species, trout for sure, salmon as well. And you get over 22 degrees and it becomes really stressful to the point where they have to evacuate that area if it's going to be a condition that persists for multiple days on end. And that's why we're interested in the numbers of days that those thresholds occur within a particular area. You can also download the files if you prefer to download actual GIS data sets and incorporate this information into your own personal GIS on your desktop. There is an option to download the files right there on the download button as well. So just as an example, for the state of Maine, this is displayed at the HUC 12 resolution. And right now I have the numbers of days per year exceeding about 22 degrees C, and that's kind of that high threshold marker that I'm interested in as a brook trout conservation minded person. And any of these areas of the state where it's dark purple, it's relatively few days, less than 1 or 2, where that threshold on average is attained. But look at all these areas in the state where we're already kind of getting into the areas where it's a concern for cold water fisheries management. And this is current condition. We can look at example comparisons under various climate change scenarios now with these modeled data. So for the state of Maine, current conditions right now, you can see we're looking at the number of stream temperature, or I'm sorry, the average stream temperature by HUC 12 watershed for the whole state. And certainly Western Maine, the mountainous area is highlighting as kind of staying in this cold, nice and cold thermal regime year round. None of this, I'll remind anybody, is kind of rocket science. This is kind of stuff that we already know just based on our experience and what we know about our state in general. The northern and western tier is still in a relatively good temperature regime for cold water fisheries management in general. You get closer to the coast and things are starting to warm up a little bit into more of the 18-20 degree C range. And this is where you start to get a little concerned for cold water fisheries management, or you have to think about strategies for allowing those fish to move to better conditions when those temperature thresholds are starting to become concerning. Now you can look at the same data under a 4 degree C climate change scenario. And I believe most of the information coming out of the atmospheric and climate change science kind of arm of environmental science in general is that we seem to be kind of mimicking, or Earth tends to be on a trajectory of about a 4 degree C climate change scenario at this point in time, with the level of change or lack of change that has been occurring at a global scale currently. So this is kind of the scenario I tend to look at because it tends to be the one that we seem to be experiencing right now. So when you look at the 4 degree C change, Western Maine is still relatively conducive to cold water fisheries management, but we're seeing more of our areas of the state dropping out of kind of those better, cooler water thermal regimes that we would prefer to see. And northern and western Maine are still being highlighted as more of a focus area that we have at least opportunities for maintaining cold water fishery management as our conditions continue to change. Now, one of the other things that is available through this tool, you can drill down into even finer scales than just a Huck 12. At the statewide level, when you're looking at patterns across a broad geography like the state of Maine, Huck 12 is the smallest watershed resolution that you can really visualize. However, when you're interested in a particular Huck 12 watershed, you can look at the individual catchments, the individual compartments within that larger Huck 12 watershed. So even though you may have a Huck 12 watershed that across the board looks like it might be on the cusp of being problematic for sustaining cold water fisheries management in a changing world, when you drill down and look at the individual catchments, really maybe you find it's just a couple of individual areas within that watershed are the more problematic ones. This provides direction on hoping to provide mitigation or provide assistance, and maybe it's helping target particular road stream crossing sites for earlier mitigation or improving passage. So at least you might be able to provide an opportunity for trout to move out of a stressful area during the summer months. That's really what we're worried about here under looking at these types of data inputs and information available that's now at our fingertips. So this is still very much a work in progress, the stream temperature model, but each year as the models are informed by additional information, more monitoring stations are coming online to feed into the models. They are improving over time. And so I'm pointing, kind of showing people that this tool now exists. It's now available to anybody to use and look at and explore. But just be aware that it is still very much a work in progress and it does change on an annual basis. So it might be something you want to look at. So that's what we're doing. We're slowly focusing in on identifying spatial areas of the state where cold water fishery management certainly can continue to exist in a changing climate. But also may provide areas of opportunity to work a little more collaborative with stewardship, and targeting individual culvert projects that might be accelerated, in whatever ways. I think we have a variety of options are now available to us to look at temperature as one of the factors to start thinking about as we develop continued collaborations with landowners and forest management in general. So with that, does anybody have any questions?
Mary, I think we'll hold up on the questions just because we're a little bit behind. So if you
Okay,
want to,
no problem.
you and Tom are headed in, and we'll ask folks if they could forward their questions in the chat. That would probably be the best at this point.
I want to stop share. How do I stop share? There we go. Tom.
Yes, hi. My turn?
You're on.
All right. One moment. Okay, how does that look?
Hey, there you go, Tom.
Great, thanks. Well, good morning, everyone. My name is Tom Gilbert. I'm a water resources specialist with the Maine Forest Service. So much of my job has to do with forestry best management practices, including proper stream crossing techniques. I also get involved in some of this aquatic habitat enhancement and aquatic habitat restoration work. I get involved with the stream connectivity stuff that Josh had talked about, and as well as some of this cold water fisheries enhancement work with using large woody debris, otherwise known as chop and drop. I'm going to talk to you a bit about our Maine Forest Service Chapter 25 rule, which will facilitate this kind of work at timber harvest. So basically, this rule provides standards for the practice of adding large woody debris into stream channels to enhance cold water fisheries. It was established in 2012, and it was put in place basically to facilitate this kind of work during timber harvest. We already have equipment on site. It's a good opportunity to do this kind of aquatic habitat enhancement work, so we wanted to streamline the process a bit and make it a little bit easier. So this is kind of an alternative to the Natural Resources Protection Act permitting process. Using the Chapter 25 rule, you can basically avoid that process and go through this alternative means of achieving that, that project. So per the Chapter 25 rule, a licensed forester can oversee these chop and drop projects without the need for that NERPA permit, as I mentioned. So normally under the NERPA process, you would need to have a natural resources agency to oversee the project. Under Chapter 25 rule, a licensed forester can oversee the project. However, they would need to receive training in the wood addition techniques. And we have training, we provide training along with Inland Fisheries and Wildlife and other partners every so often, maybe every 2 or 3 years, we provide this training. And we provide a list of licensed foresters who have received the training on our website, mainforestservice.gov. And that training is valid for 5 years. You must also, as a licensed forester, work with a fisheries biologist from IF&W or DMR to proceed with these projects. And that IF&W or DMR fisheries biologist would have to designate a stream channel as appropriate for this treatment method. And that designation would be valid for 4 years. So a lot of those areas that Mary had just showed you in that map, those really good opportunities for cold water fisheries enhancement. If you're working in those areas, it'd be great to give Mary a call and see if she wanted to have a look and designate your stretch of stream to proceed with that treatment. And there's other rules associated with Chapter 25, of course, standards they would have to follow, which I'll get into in a moment. So here is basically most, if not, I think all the information that you require on your treatment plan. It's basically a one-page paper with some basic information, including stream name, town, GPS coordinates, the average stream bank width, and the total number of pieces. And then you just need the signature of that fisheries biologist and a signature of a licensed forester. So it's a pretty brief document. And you would submit that document along with your forestry operations notification. So you would need to submit this FON along with that plan. Whether you're doing this in conjunction with the timber harvest or not, we would like to have that FON submitted. And on the reverse side of the FON, you'll find that there's a section where you can check a box off to just basically indicate that you are proceeding with this large woody debris project in accordance with Chapter 25. You would include a map along with that, with the project location identified, a copy of that treatment plan. And if your project is taking place in this Atlantic salmon area, you would have to have a DMR fisheries biologist sign off on that plan. So just a quick overview of that process. The licensed forester would be trained. We have a list of that again on our website. You would find an IFNW or DMR biologist to help you out to designate that stream channel and have that treatment plan prepared, and then just notify the Maine Forest Service with that forest operations notification. So on to a brief overview of the Chapter 25 standards. These standards were taken from standards used by Project Share, the U.S. Forest Service, and the state of Oregon. Among the things that it does, establishes a maximum loading rate and minimum size of key pieces. Those key pieces are the main the main bones of your woody debris structure, and provides some guidance on orientation and placement of those pieces of wood. So this method of adding large woody debris was really only involves wood without the use of any other kind of material like rocks or boulders. It would also prohibit any artificial anchoring of wood, such as cables or whatnot. It's really just relying on the weight of that wood to remain stable, to provide that cold water fisheries habitat. A little bit about key pieces. So again, that's the main bones of the structure, the largest tree basically involved in that structure. So we have some guidance here on that in Chapter 25, and this is something we're going to take a look at, I think, this winter, and maybe revise a bit. You can see there's some minimum lengths and minimum diameters involved. I believe that chart for minimum diameters is taken directly from the state of Oregon, which of course has very different forests than we do. So sometimes these standards can be a bit of a challenge to meet under Chapter 25. So we're having a look at this to be a little more in sync with what we have here in our state. And we have the loading rate as well. Another aspect we're going to have a look at in this winter. So again, can be a challenge to meet those minimum sizes here, but there's a maximum loading rate of 230 pieces total per mile. And the document provides some guidance on placement and orientation of these wood structures. I'm not going to get into great detail on all this. I just wanted to just show that this information is in the document. But of course, we'd want to work with your fisheries biologists and some experts in the field to get a good grasp on where and how to place these wood structures. And of course, all other standards and regulations involved with cutting wood within shoreline areas still apply. So any of those trees that you are dropping in stream channels do count towards your maximum removals in those shoreline areas. And of course, sedimentation is always a concern when working around water bodies, and have to minimize that as you would in any project. So that was my very brief introduction here of the Chapter 25 rule. Again, it's really designed to assist with proceeding with these projects, timber harvests. And this is an image here of our guidance document which contains that Chapter 25 rule, as well as some standards for placement and orientation of wood. And you can find that on our website at mainforestservice.gov in the water resources section. So at this time, I can take any questions if you have any about the Chapter 25 rule or chop and drop in general. Or unless Mary wants to continue on and take questions after that.
The only addition I would make, Tom, is I'm interested in hearing from some of the large landowners if there are ways or if they have ideas or potential stumbling blocks from their side of the story of what we could do or needs to be addressed to get more of these types of actions going on the ground. I'd like to see more wood addition happening in areas in conjunction with wood harvest, in areas that are good candidates for it. And, you know, if some of our large landowner partners have ideas on how to facilitate that, my ears are open.
Well, maybe some of the large landowners can communicate directly with you, Mary, on some of these ideas if they have.
That'd be great. I would love to hear it.
Yeah. Okay.
This is Steve. One comment that I've heard from some of the commercial forest type people is they're so mechanized that they don't use chainsaws anymore, and chop and drop, the rules apply to chainsaws, correct?
No, you can use other machines. It's more
Okay.
about controlling the sedimentation and how you do it.
Okay.
Yeah, a lot of times some of those other harvesting machines may even be a better option, being able to reach into those shoreline areas without creating too much of soil disturbance, and just reaching in and dropping those trees and placing them easier with that equipment than with felling them with a chainsaw.
Mary, this is Henning. I'll speak up as one landowner who has completed one project with you and others years ago there up on Intervale Brook near Moosehead Lake. That was our first venture into large wood additions and was a great experience. And, you know, thank you, Mary, for all your help and monitoring the fish response before and after that project. And we've had notions of doing other projects, and we have one actually partially marked out with the help of Bobby Van Riper, who I might have seen on the call today. So thank you, Bobby. We still have hopes of finishing that project. So I think my 2 cents with what are some of the hurdles is really just the coordination of it all. And it's not, and the cost, trying to figure out how to be efficient with the cost of it. We hired on that first project, if you recall, we hired a consultant out of New Hampshire with a lot of experience doing that technique. And our thought about doing this at a larger scale, because as you and Tom have mentioned, getting a more impact onto the landscape is really what's needed, and one-off projects helpful. Scaling this up is really where it needs to go, and so we did train some contractors of ours, some logging contractors, and the thought was, like you mentioned, when there's adjacent harvests, to have that logging contractor move over to an already permitted. We do all the homework, all the tree marking, etc., and that trained in the technique contractor could then implement that that stream reach. And perhaps, you know, that would be a cost to us. We'd have to pay that contractor, but it would not be perhaps the same cost as that specialized consultant on our first project. So we've yet to kind of do that, but there's a lot of coordination in terms of marking those trees along the stream reach, having that trained contractor, having that adjacent forest management block, and all those little pieces coming together.
Yeah.
So that's, you know, that's really been our hurdle, and it's not any, you know, not any one of those little parts is the hurdle. It's kind of all of it together. So
Yeah.
a little bit of my personal experience.
Yeah, it does require a series of moving parts. And Tom alluded to it. We're going to try to address some kind of the discrepancies in the actual rule itself, just to kind of make implementation a little easier from both sides, from our side in the state, as well as you guys out in the field cutting wood. The other thing that, you know, we just have to find the time to meet and look at a site, or you know, even if you guys are planning a harvest, you know, however far down the road in a particular parcel, even if you can delineate that on a map and send me an email so I can get out there and look at the site and then kind of start planning a project if you think it might be something you want to do. I think there are additional ways that we can coordinate better on this stuff, and I'm just curious on what might work more effectively for you guys.
Okay, good. Well, thank you both for those good presentations. To continue to try to maintain our schedule here, which we're doing, cross my fingers, we're doing very well. It's a good job by everybody. Steve and Christopher, you folks are up.
I'm working on it.
I can tell by the look on your face, you're putting a great deal of effort.
There.
Perfect, you're up.
Now let's see if it moves now. Anyway, so Pat wanted a title, and we can get a nice fancy scientific title, or we can just do it nice and simple, that wood is good. That's taken from John Fields, a fluvial geomorphologist who does this stuff for a living. What you're looking at here is, well, actually, let me start out by introductions, because there's a bunch of names on this call that I actually don't know. I'm Steve Koenig. I started with Project Share January of 2000, so I'm finishing my 20th field season. Share was created in 1994, catalyzed by the commercial forest land base, to be a stakeholder group, conservation group focused on Atlantic salmon recovery, primarily concentrating on habitat. I've been the executive director for 19 years. In January, I passed the torch on to Chris Federico, who's also on the call, who's the new executive director, as I slowly aim towards something called retirement on a schedule that is kind of abstract. We have concentrated for years on connectivity in focused areas. This is the top of the Narraguagus at Route 9. All the road crossings that are perennial fish-bearing streams have been addressed by either Share or the landowner associated with that land base. So connectivity is complete up here. However, we have a problem with habitat suitability. Overwidened streams, warm water, particularly of our main stems, is a landscape problem with all of our down east rivers and rivers in Maine. Oop, how come, there we go. So to start with, I want you to take a moment to look at each of these pictures and think about what you see. This is a little bit more obvious. This is bigger water, a little bit different. What do all of those pictures that are all coming from Maine rivers have in common with this? I don't know where this is. I stole it off the internet. But each of the pictures you just saw is a not so quite obvious version of this picture. A lot of reaches in all the rivers of Maine are pristine looking natural ditches. Kind of blunt, but will hopefully get your attention. This is a landscape problem, not only in Maine, but all of New England, Canadian provinces. We took these practices, shipped them off to the Midwest, and then eventually shipped them off to the far west. The Machias River log drive, 1971, I believe, was the last year of the log drive. Machias was founded as a settlement in 1763. 1763. One of the principal reasons is for lumber. In 1764, 1.8 million board feet was generated. In the heyday of the mid-1800s, it was 40 million. It reduced down by the end of the 1800s to 10 to 20 million board feet per year. Those years, the picture you're seeing here is 70 years after the 1800 heydays. And look at what's going down the river in 1971. So for 200 years, this happened to the Machias River every year. And if you consider that after 200 years of harvest, the trees are getting smaller and smaller and smaller. So what went down the Machias River and what did that do to the river? Coupled with the actual drive, in the 1840s, the Machias River Dam and River Improvement Company was chartered by the state of Maine legislature. We know what dams are, but what are river improvements in 1840? What does that mean compared to what Mary would think they mean today? The river improvements were to facilitate using the rivers as the transport mechanism, which means taking out obstructions, be it large boulders, glacial erratics, wood jams that occurred in the river, straightening the river, that type of thing. This is an area of the west branch of the Machias aerial. Current Google Earth. So this is 50 years after the log drives ended. You still don't see a stick of wood. You can look at aerial photography on any of the down east rivers and you have miles without being able to see a stick of wood, and the rivers look like this 50 years after the log drives ended. I come from northern Michigan. I grew up sailing on Lake Huron and paddling rivers in northern Michigan. When I came to Maine and paddled these rivers, they just look strange to me because there's no wood in them. How can that be decades after it happened, as far as the log drives ending? This picture will kind of give you a hint of that. Down east rivers, we have very good forested buffers adjacent to rivers. It's hard to find a spot that you don't have a forested buffer. However, look at the size of the trees. The trees of today are forested buffers of a young forest, which means small trees, compared to this stump of yesteryear. This is a little bit of history, Maine. 1872, a master pine measuring 5 feet, 8 inches across the butt, and the first log produced 6,000 board feet of timber. 1884, a master pine located in Washington County. This tree was over 300 feet tall. This is in the late 1800s, 100 years after harvest was already occurring. They were still finding some trees of this size. What did the trees that were originally along the Machias, the Narraguagus, other rivers in Maine, what would the size of those trees have been? When they fell into the river, by whatever means Mother Nature put them into the river, they were big enough to stay put. The problem we have today with these smaller trees is if they do end up in the river, they're not big enough to end up as key pieces. So years after the log drive ended, you still don't have the accumulation of wood, particularly in the bigger waters. So that's a problem that we have as far as landscape. We do not have trees right along the river to a great extent big enough to create the wood that the wood requires. Another problem, my perception is another problem that we have relates to this comment. The Machias River ranks with St. John, the Allagash, and the Penobscot as one of Maine's most scenic and outstanding paddling rivers. So what I'm calling a very nice natural looking ditch is publicly perceived as scenic and outstanding and pristine. So in some sense, that's actually true. We have rivers that don't have a lot of development on them. However, ecologically, they are not pristine. So what we're going to be talking about is the loss of complexity. Ben Naumann's on the call. This is actually one of his projects when I can't even remember how long ago this happened, but he, was worked for Project Share, putting wood in. This is 35 Brook. This river looks as straight as an arrow because the banks are actually lined with logs to straighten and protect the bank from the effect of the logs going down this. This is a tributary of the Narraguagus. The Narraguagus was driven, so were the tributaries. And this is a project that Ben implemented as far as adding wood. The other comment before we just get into, I'm just going to do a few pictures of some of the techniques we're using, is we're talking about wood additions, but I strongly recommend if you want to get into river improvement for the ecology of the river, think holistically. This is midway up the top of the Narraguagus. Remember, for the past 10 years, we have been doing every road crossing, so the connectivity is done. You don't see much in the line of wood here and here. This is what we call the campsite. There's a natural jam here, but in investigating this jam, we found a block channel. This is the main stem went along here. If you can see my cursor, I hope. We opened up another channel, but there's also another channel that's lost to history over here that may have been the original main stem. So in thinking about wood additions in this area, we're also looking at other things to do with the river to open these up and do more than just a treatment of wood. So wood is a key and missing component of natural river ecosystems, statewide, region-wide. We can go through a lot of lists. Wood is responsible for pool formation, floodplain connection. Without obstacles and roughness in the channel, when you have a high flow event, it's staying in the channel. If you have a wood jam in there, what happens is the water hits that roughness and goes out into the floodplain the way it's supposed to. Wood's responsible for helping with sediment sorting, retention of allochthonous nutrients. The primary productivity in river systems comes from the land. It's leaves, twigs, material that is primary productivity in the land that makes its way into the river. Without the wood structure in there, it's just being flushed downstream. Hyporheic exchange, that has to do with the water in the stream channel interacting with the structure of the bottom and actually having a cooling effect with groundwater, et cetera. And really the channel formation dynamics. If you have a ditch, water goes straight through it uniformly. If you have obstacles in that ditch, it affects the current velocity, which then works on, that's the power of the river doing its thing. So chop and drop, which Tom just talked about, is where we started years ago, basically knocking down a tree. I'll give kudos to Alex and Jed, who was previously mentioned. One of our first projects is down east was on Kramer. Was it Kramer Brook? In the East Machias, Alex probably can tell a wonderful story with regard to how much went into designing this, what went into expertly placing the wood, and probably within 2 weeks of that placement, you had a high water event. Guess what? Wood floats, and all the wood treatment ended up in a jam outside of the treatment reach. So what do you call failure? Creating a jam in that tributary ended up being a good thing. It just didn't happen to keep up with the design, thanks to Mother Nature. We do grip hoist additions. The difference here is we have basically industrial strength come along. It's a cable winch that by hand, we pack it in and we actually pull the trees over. You can see with this root wad attached, a third to half of the roots are still attached, creating an anchor on one side. And if you have a piece of wood big enough to lock in place on the other, better chance of staying put. Here's another grip hoist addition. This is on the main stem of the Narraguagus. This pretty big root ball. This tree went across perpendicular, and this single tree, most of the water is flowing in here, and we're getting a pool development. This area is entirely embedded, which means all the cobble is covered by fine sediment to the extent of that's why all this vegetation is here. This probably happened about 3 years ago, and the water going over this single log and underneath this single log is actually creating a pool and moving the bed. That's exactly what we want to happen. This one, if you look at the title, Grip Hoist Wood Additions and Mobile Wood Additions, here's another one of our grip hoist additions. In this case, we had an excavator harvest trees off channel, brought them into this area, and we took this cable winch and dragged, rolled full-length trees and created these pretty good-sized jams. This is what it looked like. This is what it looked like about 2 weeks later, after a rain event. Guess what? Wood floats. And so what was weeks of brutal labor, rolling trees upstream, actually ended up not being too bad, because the natural jam of the campsite is just downstream of here, and a lot of this wood ended up there. But it was 2 weeks of work that Chris still tells me about. So this is that same treatment. We funded by NRCS. We did a pilot of post-assisted log structures, or PALS. Again, everything we do is stole from the West Coast. There's a particular group out there using this. So here we're creating these structures, and then we have a portable post driver that these are actually posts to try to key things in. In the bigger water, the trick is how do you get things to stay put. So some of these have worked, some of these have been moved by the bigger water, but we're slowly learning over time. So here's some more of them. This is the campsite. This is what we would like the river to look like. One obstacle we have to deal with is normal people who aren't biologists, who are thinking about the fish, think this is a mess. And we've actually had to educate the people at this campsite that this is pristine Atlantic salmon habitat. You have a pool that's formed in this area. There originally was a natural jam that we've been adding to enhance this and expand the impact of what Mother Nature started here. Getting back to the bigger water at Route 9 in the Narraguagus and where we're going on this. It's been a long time coming. Looking at this particular leak started almost 20 years ago with Jed Wright, who's been mentioned, and geomorphologists. These are actually engineered jams. And this is what we're in the planning stage after all these years for the Narraguagus. We've been working on the permitting and design of this for about a year or so now. And we have funding that will be implementing this project next summer. Basically, here in these general areas, 5 of these engineered structures we put in place. When we talk about holistic, what we also discovered here, this is the modern channel. There is an old floodplain channel way over River Wright that may have been the original main channel of the Narraguagus in the area. And there's some very cold water along an esker over on this side. We want to get some channel formation along with putting structure on this side is activate water going back over into this old channel. This was some work done this spring in preparing for it. In order to build the structures, we had to determine, did we have bedrock? Could we get them in deep enough? I put this project in to show that things can be done. This is actually the engineer, checking out the depth of the pool or the dig to see how far bedrock was. Wendy Mahaney from Fish and Wildlife Service, who's a key person on the permitting side of it, was on site. Anything that we do that's new and different and impact, Wendy knows about. Started planning this years ago when I asked her what would it take on the permitting. And by the way, if you look here, the excavator in the river is going to have a U.S. Fish and Wildlife Service emblem on it. And that's actually what happened. So stay tuned. We're going bigger with our wood additions. And this project has been a long time coming. We'll see how well we can pull it off. So in finalizing a couple things is a little bit of wood doesn't do much as far as stream ecology on a large scale. Over the years, in the top of the Narraguagus, this is kind of a summary of the different wood additions. We're just getting started. And the final thoughts I'd like to leave you with is every river in Maine was driven for 200 years. Complexity was intentionally reduced to facilitate the log drives of yesteryear in every river in Maine. Rivers are locked in this new altered state, and because of all these changes, there's little chance that they can undo the state they're in on their own, particularly the bigger water. Tributaries, you have trees that can fall in and span and create wood additions in the smaller headwater streams. What I'm talking about more is the bigger rivers that trees have to grow for another 100 years in order to get to the size large enough to actually fall in and stay put. So this wood retention requires key logs. So if you're thinking about the wood, it's not just getting the wood in, but how do you get it to stay put? Another thing, in talking with geomorphologists that we are teamed up with, the fundamental question of how much wood is really needed to catalyze stream ecology, you can't get a good answer to that. So basically, we're going to be adding wood into this part of the Narraguagus until we start getting a bed response of the river channel itself, which is going to lead to habitat creation by the river. On the positive side, wood additions are not rocket science. You know, we're talking about isolated areas without having to worry about infrastructure versus, you know, where wood is used in a city setting, et cetera, et cetera. We just have to worry about the Route 9 bridge. So Mother Nature, be it a tornado or a wind event or bank erosion, just dumps a tree into the river. So on one hand, you have to do things right, but we're not really talking about rocket science compared to, you know, designing a bridge. So caution, we need to get some of this done and we don't need to overthink it necessarily, assuming we can get permission from the state and federal persons associated with permitting. So the other thing to consider is biologists, and that includes someone like me, specialize in biology. Commercial foresters and contractors know how to handle large wood. You do this for a living with equipment designed to do this for a living. Some of the foresters I work with probably thinks we're out of our mind if they watch us on site and what we're doing by hand. But that's the option that we have, you know, kind of thing. So what I'd like to leave you with is if you represent a land base that would like to do this stream type of ecological positives for the stream, you deal with commercial people with equipment capable of handling large wood. You're not in the business to be biologists restoring streams, so the obvious thing is to team up. And we're doing this more and more interest with the commercial land base that we deal with. Some of the foresters, they're communicating when they're going to be doing a cut close to the river. We haven't pulled off to the extent that we want to, but rather than you as a commercial forestry operation dealing with all the ins and outs of the wood additions, my recommendation is reaching out to see if you can, you know, key into something like a project share or an IF&W or DMR biologist who have the time and capacity to help you be responsible for some of the stuff that's out of your wheelhouse, and you add in, you know, the ability to handle this kind of wood. So just wanted to acknowledge some of the different entities that are involved with what we're doing, and particularly in the Narraguagus. It's truly a team effort, and I'll leave it at that.
Great, Steve. Any questions for Steve or Mary or Tom? It was all on a similar topic. Just one comment from me. I did some quick calculation on wood that was coming down the Machias as for numbers that you mentioned, Steve, and at the height of it, you're talking the equivalent of 7,000 trailer truck loads of wood annually. So these weren't small endeavors. We have any questions, folks? So we've got a couple minutes, but we do need to get on break in preparation for the next session.
Pat, I have a question.
Yeah.
I was just wondering if Steve or Mary or Tom, with some of these projects, you know, we've been involved with chop and drop and some of this more elaborate stuff that you're talking on larger rivers. I understand it. I'm sure some of the groups that represent fishermen understand it, but how do you coordinate with, or do you see any conflict with recreational groups, those that like to paddle the river, to get them to understand some of this? Or probably some fishermen you mentioned at the campsite, they didn't really get it until you explained it. So how do you address that?
To start out with, I come from Michigan, and paddling, like world famous Au that kind of thing. Paddlers have chainsaws. And in Michigan, it's actually against the law, and I think in Maine, it's against the law to deal with this. However, who's going to catch somebody out in the middle of in the woods? The fortunate thing that we have on the Narraguagus is the land base is closed off with gates during mud season, which happens to be the time of year when this part of the river you have water. And so it's not as much of a problem. As we move into the Machias, that's totally different, is we will have paddling conflicts, and we have to be aware of that. But particularly if you're thinking brook trout and not Atlantic salmon, there is a tremendous amount of this work that can start in smaller tribs, and particularly larger tribs, that are just not paddled. So start where you don't have conflicts. You're also talking where you're not going to have conflicts with Mother Nature undoing everything you're trying to do. That's my first thought. Also, real quick, I just see Chris just came on board. If you just want to say hi, Chris, type of thing. He is Share's new executive director. He's very good. He has skill sets that are in some cases better than mine. And hopefully this group will get to know him over the course of the next few years.
Perfect.
I would just add, from the brook trout perspective and side of things, really the best candidates for chop and drop, wood addition, like the style that Tom was talking about, it really is focused on true headwater streams, your first order, maybe some of your second order forested streams. So those areas tend not to be paddled. They're just too small. And actually they're not fished terribly often either, simply because it's not kind of the style of fishing that most anglers do here in Maine. But there are avid stream anglers, and those who are into that style of fishing tend to understand the role of wood.
And wood isn't carried away quite as easily in these headwater streams either. So the weight of the wood structures themselves are often adequate.
Great. Thank you, everybody.